Okay, this is lesson 81, and it's on the law of cosines. I've written out a little bit to start out. You have used different ways to solve for a triangle, and so we're just going to review the different ways to solve for a triangle. So first of all, to solve a triangle, you need one side and two other parts, and it doesn't really matter what two other parts it is, but so far, these are the situations we've run across. There are three ways to solve a triangle. First of all, if it's a right triangle, you just use sine, cosine, or tangent to solve it. You just use your normal trig function, so katoa. Okay, so that you are really familiar with. If it is not a right triangle, then we go down to these other two. So if a pair is known, then you use the law of sines. So let's review pair. Again, a pair is an angle and its opposite side. So if we come up to this triangle here, a pair would be angle A and side A. That is one pair. Another pair would be angle B and side B. That's another pair. And then the third pair would be angle C and side C. For the law of sines, you only need one pair. You have to have a pair in order to solve it. And if you remember the law of sines, again, it was the side over the sine of the angle. So A over sine of A equals B over sine of B equals C over sine of C, and you solve it. But you have to know one pair. Okay, if you don't have a pair, then we go to our third option. Our third option is using the law of cosines. Okay, and that's what we're going to talk about today. But let me jump back up here really quick. If you do have a pair, you have to remember that when you use the law of sines, you have to be aware of ambiguity, because the law of sines is always only going to give you the first quadrant. So if you get 30 degrees, it could be either this angle or it could be this 30-degree angle. And so in that case, it's not actually 30 degrees, it's actually 150 degrees. So you have to be careful of that. If you're never going to get 150 degrees as an answer, it's always going to be 30. So you have to use your common sense and see if it's going to be an obtuse angle or not. So that goes back with the pair of sines, or the law of sines, and we will have a couple of examples like that today. So if you're confused with it, we'll go back to it. Okay, so now we're going to learn about the law of cosines. The law of cosines, in your book they list it three different ways, and I'm not going to list it all three different ways, but you can look and see. It's on page 489. But what I am going to do is I will list it the way that they use it in the book, so that it's not confusing. So this is the law of cosines. The law of cosines says p squared equals a squared plus b squared. So this should look very familiar to you. And then it adds in a second part. It says minus 2ab cosine of p. Now what you want to keep in mind is that p and p are the unknown sides and angle. So P is the side and capital P is the angle that you don't know. So we'll use the law of sines the law of cosines to try and solve a couple of problems. So first of all, let's look at this triangle. You have a triangle that has angle Y, a 36-degree angle, and angle M. Side X, side 7, and side 10. Okay, so we don't have a pair because 36 goes with X, 7 goes with M, 10 goes with Y. There's not a distinct pair, so we cannot use the law of sines to solve it. So we're going to have to go to the law of cosines. So let's start and let's see if we can figure out what X is. So we're going to let X equal our P and 36 equal our capital P. Okay, so if we want to solve for X, we'll plug everything in here. So P squared is actually going to be X squared a squared, remember lowercase, those are your sides. Order doesn't matter, so you can let a be 7 or 10. So it's going to be 7 squared plus 10 squared minus 2 times 7 times 10 times the cosine of capital P, which is 36. Okay, here you can just plug that all into your calculator, and we'll see if you can see. Let's see. So in my calculator, I'm just going to do 7 squared plus 10 squared minus 2 times 7 times 10 times cosine of 36. And hit enter. I get 35.74. And then I'm going to square root it. So the square root, my answer is 5.98. So x equals 5.98. Now these problems are quite long and involved because it says you have to solve for all of the triangle. So far we have x, we still have to figure out what y and m are. But now we have a pair, so we can use the law of sines. We don't have to use the law of cosines. You can if you want to, but now you have all of these other options. So I'm going to just set up the law of sines. So using the law of sines, we know that 5.98 goes to the sine of 36, as 7 goes to the sine of m, as 10 goes to the sine of y. Okay, so 7 sine of 36 equals 5.98 sine of m, divide by 5.98. So we get the sine of m equals, I'll plug that into my calculator again. So I'm going to do 7 sine of 36 divided by 5.98. I get 0.68. I have to do the inverse sign, so I do second sign and then second and then the negative sign so I can get my answer, and that gives me 43.48 degrees. 43.48 degrees is m. So now I have m, I just need to find y. You can do it using the law of sines, or you can use what you know about triangles, that the angles always add up to 180. That's what I'm going to do. I know 43.5 plus 36 plus y equals 180, and so y has to equal 180 minus 43.5 minus 36. So y is 100.5. Now, one thing that you're going to notice is if you use the law of sines to solve everything, or if you use the law of cosines, your degrees are not always going to add up to be 180, and your answers aren't going to match exactly what's in the book. As long as they're close, as long as they're, I would say, to the nearest tenth, you should be okay. So our final answer, we know x equals 5.98, y equals 100.5, m equals 43.48. Let's see, is that everything? X, y, and m? Yep, those are our answers. So 5.98, 100.5, and 43.48. And you'll notice that my answers are just a little bit off from what's in the book, but that is fine. Again, they're close. When you round, you just run into those mistakes or those differences. So let's do one more, another triangle. Let's do 81.2. says solve this triangle. So we have 7, 5, y, x, z, and 8. Okay, in this case, you'll notice you don't have any pairs, so you cannot use the law of sines, so you're going to have to use the law of cosines. In the example, they decide to figure out what x is, so x and 7 is what they're going to use. So let's go back to p squared equals a squared plus b squared minus 2ab cosine of p. Okay, so our p squared is our length, so 49 equals a squared, a squared, which is 5 squared, plus 8 squared minus 2, that's a b, 2 times 5 times 8 cosine of p, which is our x. So we have 49 equals 25 plus 64 minus 80 cosine of x. So let's see. Let's just do this really quick. This is 89 minus 89, so we get minus 40 equals minus 80 cosine x. If we divide by negative 80, we get 0.5 equals cosine x. So so x is going to be the inverse cosine of 5, inverse cosine of 0.5. So inverse cosine 0.5 is 60. So we know x is 60 degrees. So x is 60 degrees. So now what I'm going to do is I'm going to use the law of sines. So 7 is to the sine of 60 as, and we'll do y, as 8 is to the sine of y. So 8 sine of 60 equals 7 sine of y. 8 sine of 60 divided by 7. Put that into your calculator. You get 0.99 equals the sine of y. So do inverse sine of your answer. We get y equals 81.8. So if y is 81.8, so we have 60 plus 81.8 plus z has to equal 180. Oops. So 180 minus 60 minus 81.8. We get 38.2. Z is 38.2. And those are the parts that we needed to know. X is 60, y is 81.8. Now, in this example, you can see it's obvious that all of those angles are less than 90 degrees. We don't have an obtuse triangle. The next example that we're going to do will have an obtuse angle, so that's when we're going to have to deal with that ambiguity we talked about earlier. So, 81.3. Solve the triangle for its unknown parts. You have a triangle that looks like this. Okay, so you have 10, 14, and K are the sides, 28, M, and B are the angles. We do not have any pairs, so we cannot use the law of sines. We have to use the law of cosines. So p squared equals a squared plus b squared minus 2ab cosine of p. You can pick any pair that you want. The book they use cosine of, let's see, they use 28 and k, so we'll just do that. So k squared equals 10 squared plus 14 squared minus 2 times 10 times 14 times the cosine of 28. So k squared equals, plug it into the calculator, 10 squared plus 14 squared minus 2 times 10 times 14 times the cosine of 28. So we get k squared is 48.77, square root, k is 6.98. Okay, so if we look at this, k is 6.98. So it's obvious that this side is shorter, these two are longer. So when we get the angles, it should go 28, then B, then M in terms of size. So we'll check that out when we use the law of sines and make sure that that's the case. So we can say 6.98 over the sine of 28 equals 14 over the sine of M. I'll go ahead and solve that. So we get 6.98 sine of M equals 14 sine of 28. Divide by 6.98. So sine of M equals, so now when we do this, we'll do 14 sine of 28 divided by 6.98. You get 0.94, take the inverse sine of that. We get 70, M equals 70.33. So M is 70 degrees. When you look at that, that is not a 70-degree angle. It's bigger than 70 degrees. And actually what it's saying is that this angle here is 70 degrees, the 70.3. So that's that ambiguity we talked about before. So you need to subtract that from 180. 180 minus 70.3, and you get that M is actually 109.7. So M is 109.7. So our angles are going to be, we have 109.7 plus 28 plus 28, subtract that from 180, and we get B equals 42.3. So B is 42.3, M is 109.7, and K is 6.98. Again, it's slightly different than what's in the book, but that's because that's what happens when you are using the trig functions and you're rounding. The rounding makes it vary slightly. All right.